Okay, in applications of right triangle trigonometry, sometimes they refer to an angle of depression or an angle of elevation. So before we step into these problems, for instance, trying to find a particular distance, how far a boat is out at sea with respect to a lighthouse, we need to know what the angle of elevation and the angle of depression means. So an angle of elevation or an angle of depression is the angle that is made with the horizontal. And this is an application, the angles of elevation, angles of depression, that are referred to also when we're talking about parallel lines cut by a transversal, because that's exactly what happens. You've got a horizontal, so you'll have a horizontal, and you'll have an angle of elevation, and we call that an angle of elevation because it's going up. Okay? However, that angle of elevation, this angle of elevation, is the same thing as, from above, the angle of depression. So what's important to note here is that angles of elevation and depression, angles of elevation, angles of elevation, and angles of depression are always made, this is important, always, not sometimes, always made with the horizontal. So you can see that when we've got these angles of elevation and maybe an angle of depression, I can say, well, I've got a tree here, right? And the angle of depression from the top of the tree is a certain measurement, right? And the height of the tree is 20 feet. So the angle of depression from the top of the tree to a person standing on the ground is a certain measurement. I'm going to call it X degrees. How far away from the tree is the person? So if the tree is 20 feet tall, and let's say the angle of depression is 30 degrees, can we find this distance right here? Can we find how far the person is from the tree? Well, we're talking about an angle of depression, so we're talking about this green portion right here. Well, absolutely, because now what we can do is we can say alternate interior angles are congruent, and we can move this 30 degrees down here, right? And now we've got a triangle. I could even kind of look at this as the rectangle that it is and see that you've got your two congruent triangles. So it all comes together now. All of it comes together. All the work we did with parallel lines being cut by a transversal, our work with quadrilaterals and parallelograms, it all comes together right here. So let's see this problem that they're talking about. Suppose an operator at the top of a lighthouse sights a sailboat on a line that makes a 2-degree angle with the horizontal line. The angle between the horizontal and the line of sight is called an angle of depression. The angle between the horizontal and the line of sight. So you've got someone at the top of the lighthouse. Their angle of depression is made with the horizontal and whatever it is that they're looking at. And then what we can do is we can create this triangle right here, this pink triangle, which is congruent to this green triangle. So they're going to give us this angle up at top that I marked with the green arc, and that's going to end up being congruent to this angle right here. So at the same time, a person in the boat, so here's the person in the boat, must look up to the person in the lighthouse. That's an angle of elevation. So the pink is the angle of elevation, looking from the horizontal up, line of sight to the person at the top of the lighthouse. The angle of depression is the person at the top of the lighthouse with the horizontal from that person, looking down, line of sight to the person in the boat. If the top of the lighthouse is 25 meters above the sea level, the distance x between the boat and the base of the lighthouse can be found two different ways. So here I'm going to redraw. We've got our lighthouse. There's our lighthouse. Okay. Then we've got our boat. There's our sailboat. And I'm going to draw that angle of elevation. That's 2 degrees right here. That's not drawn to scale whatsoever because I needed room to write. But I could also draw this with the horizontal being up at the top of the lighthouse, line of sight looking down, and we'd have our 2 degrees right there. So notice how our angle of elevation 2 degrees in red, is made with the horizontal, and our angle of depression in purple is also made with the horizontal, never with the vertical, never, ever, ever. They also tell us that the top of the lighthouse is 25 meters, so from the bottom to the top, 25 meters. The distance x is from the boat to the bottom, the base of the lighthouse. Can we find that distance x? Well, that distance x is the same as this distance x above because we make a rectangle. Either way, I'm going to circle my reference angle, draw an arrow going to the opposite side. X is the adjacent side. Opposite and adjacent, not sine, not cosine. It is indeed tangent. So we're going to write the tangent of 2 degrees is equal to 25 over x. I'm going to cross multiply and divide. So I'm going to multiply both sides by x. Or I can just think of it as cross multiplying. So x times the tangent of 2 degrees is equal to 25. Divide by the tangent of 2 degrees. Make sure you've got your calculator handy. And we're going to get a distance. It's going to be in meters. Definitely going to be in meters. The tangent of 2 degrees. Let's do 25 divided by the tangent of 2 degrees. And I get 715.9 meters. 715.9 meters. Now, there is a second way with different numbers to find. I'm going to highlight the 2 acute angles in a right triangle are complementary. So this angle that's made with the vertical is 88 degrees. So if 88 degrees became my reference angle, x would be the opposite side and 25 would be the adjacent side. So I'd have the tangent of 88 degrees is equal to x over 25. Now when I cross multiply and divide, I get x equals 25 times the tangent of 88 degrees. I'm going to put that into my calculator, and it is absolutely no surprise whatsoever that I get the same exact number. So there's 2 different ways that we could have written an equation to solve for x, and either way is absolutely correct. Either way is absolutely correct. So now what we're going to do is we're going to determine whether or not we've got what types of angles we have. So what angle is this? So we're going to give the number of the angle and its special name when a person at H cites T and blah, 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 blah. So we're going to come back in the next video and we're going to finish that up.